Alright then, so here we go with question 5. A person pays $5 to play a game with a pair of coins. 2 heads appear, then $10 is won. If a head and tail appear, $3. If 2 tails appear, then $1 is won. Alright, so X equals the profit per game. So we have to unpack this a little bit. So there's a table of values here, but let's just create our own table of values. We're really looking for the number of heads that appear. Okay, so let's have Y equals the number of heads. When you throw 2 coins, you can get 0, 1 or 2 heads, and it should be quite easy to get the probabilities here. So that's how we would start. But now we have to think about how much cash is won. And so if I just put down here, carry on the table, let's put cash here. If 2 heads appear, then $10 is won. If a head and a tail, then $3 is won. If 2 tails appear, $1 is won. Alright then, so now we can start to get towards this table here, because now we check out the next variable is the profit per game. So this is the important piece here, that we actually want to get towards the profit per game, and if we think about it, we're paying $5 per game. So the profit is winnings minus outgoings really. So now we can see how to get the X variable. So if I think about win 10, having paid 5, that will be a $5 profit. We win 3, having paid 5 to play, then that clearly is a loss. So that's a profit of negative. And the final thing, which you can see here, is pay 5, win 1 back. This will be a -4 profit. And so we can fill in the table of values. And now we can answer the rest of the question, because the expected profit is just E of X. And E of X is quite easy to get from our calculator. So E of X is just the mean. So let's create a table of values in here. If I just make this big so we can see it, doc, insert a list in spreadsheets. This will be X, and notice if I press X here, it already populates 0, 1, 2, 3, 4. That's because I've got an X somewhere else stored as a variable. I think I must have deleted it. So I'm going to call this Y instead. And I'm just going to delete all of these numbers here. Another way of doing this, actually, I'll show you here, is that if you start to type in any variables in here and they've already been used, the best way around it is doc, insert a new problem, and now add a list in spreadsheets. Now if I go back to here and put X in here, you can see it's not bold anymore. As soon as you start a new problem, set 2 point here, then it resets all the variables and you're able to use any of them. So I think I like that better. So now X values are, if I go back to my question, so the X values are -4, -2 and 5, and these are going to be the probabilities, and the probabilities are 0.25, 0.5 and 0.25. Click in the next column and then menu, statistics, stat calc, and it's a 1 variable statistic. Remember, the variable is X, the profit per game. There's only 1 list, and the X list is the variable X. The frequency list, don't forget, is the probabilities, and off we go. And there, in fact, is the mean. So E of X, X bar is -0.75. So we go back to our question. The expected profit per game equals -$0.75. So from the perspective of the player, on average, you're expecting to lose you're expected to lose $0.75 per game. This is not a great game to play in the long run.